Okay, so hello and welcome back. Now in this video we want to essentially compare some numbers, meaning that, for example, over here if we have an exercise that says that circle the smallest number or circle the biggest number or find the numbers hidden under the paw, and so essentially the numbers have been written in an ascending order, and so on and so forth. We want to do that, right? Now, in order to compare numbers, of course, you can, when we get to a little bit advanced mathematics, we can compare numbers essentially using algebra, for example. That's possible, and that's, of course, easier. But at this stage, and I'm, making the assumption that I'm explaining this for this stage. Later on we will make it more advanced as we go along. Okay, so let's say that, for example, we have essentially these numbers 8, 12 and 6, for example, and I want to find the smallest number, right? So how do I find the smallest number? So to find the smallest number, I have to compare these numbers, right? And whenever it comes to comparing numbers, basically you can always compare two things at a time, not more than two. Meaning that, for example, I have 1, 2, and 3 numbers over here. So all the 3 numbers, I cannot compare them at the same time. I have to pick 2 of them, compare them, and then whatever I get from that comparison, compare it with the third number. There is no other way to do that, right? So from these two numbers, I'm going to pick, for example, arbitrarily 8 and 12, for example. Now I have basically 8 and 12, and I want to compare them for the smallest number. Now, one way to do this is to say that essentially an 8 represents, for example, 8 beats, for example. That's essentially one of the models that we use essentially for our numbers. So an 8 would be 2, 4, 6, and 8 beats over here. So essentially that's essentially an 8, right? This is an 8. A 12 would be 2, 4, 6, 8, and 10. So I have essentially a 10 over here. I have essentially a 10 over here and a 2. So these two, when I put them together, that becomes essentially a 10, and a 2 would be a 12, right? Now, to compare these numbers, essentially you will just simply compare the number of beats, meaning that you count. So I have 8 beats over here, so I can pick 8 beats over here, and then I can see that this number still has 4 more beats, meaning that 2 beats over here and 2 beats over here. And so since this number has essentially a larger number of beats, that means that this number is greater than this number, right? So then I can say that essentially a 12 is greater than an 8, and of course you use the greater than and smaller than signs for comparing numbers. This is greater than, and this sign over here is smaller than. Okay, so then based on the number of beats, I can say that 12 is essentially greater than 8, or essentially the same thing, I can write it as 8 is smaller than 12, right? 8 is smaller than 12, right? So then this way, now I know that essentially that 8 is smaller than 12. So I can essentially erase all of these things over here, and I can just simply write essentially 8 is smaller than 12. And then since I'm looking for the smallest number, I will pick essentially my 8 over here, which is the smallest number, which is the smaller number, and then I will compare it with the 6 over here. So then I can say that, now I can essentially compare 8 and the 6. And again, I can do the same thing, meaning that I can essentially represent the number 8 using the number of beats over here, like this, and 6 using the number of beats over here, like this. And then I can say that, I can argue that I have 6 beats over here, and these are my 6 beats, and it seems that this number essentially has 2 beats more than this number, which means that then this number is greater than this number. So then I can say that essentially 8 is greater than, I can say that essentially 8 is greater than 6, and which essentially means that 6 is less than 8, which means that 6 is the smaller number. So now essentially we have essentially in the first comparison we saw that essentially 8 is less than 12, and then 6 is less than 8, so that means that 6 is the smallest number, right? That's essentially one way to compare numbers. And of course you can do the exact same thing if you were to be looking for essentially for the greater number, for the greatest number. Meaning that if you were looking for the greatest number, you would still do the same comparison. Over here you would have the greatest number, and then you would, for example, pick these two numbers and compare them. 8 and 12, you would compare them. For example, 8 would be, for example, this number over here, so this would be your 8, and your 12 would be 2, 4, 6, 8, 10, and a 12, so this would be essentially a 12. And now I can compare, so I can say that, for example, I have 8 beats over here, these are my 8 beats, and then it seems that this number has 2 and 4 beats more than this number, which means that essentially a 12 is greater than 8. And then in the exact same way, essentially, so that's 12 is so far is the greatest number. Now I can compare 12 and the 6 over here. And again, I can say that basically this is 2, 4, 6, 8, and 10, and 12. This is my number 12. And then the number 6 is right over here. And then I can compare. I can say that, for example, this is my 6 beats. So I have my 6 beats over here. And then it seems that this number has 4 and 6 beats more, which means that 12 is greater than 6. And so then 12 is the greatest number, right? So that's basically how you compare numbers using the number of beats, which is of course something that you cannot use for a large number. Meaning that, for example, if your number was 128 or or 2556, for example, then you would be counting and counting all the way up to eternity, and that would not be very easy, although we haven't gotten to those numbers yet. And then when we get there, then we essentially come up with better ways to compare numbers. Okay, now another way to compare numbers is, for example, the exact same numbers that we have over here. You can write your numbers in an ascending or descending order. So you know that essentially numbers, the way that we have talked about them essentially up to now, we have the number 1, we have the number 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth, right? So, and of course, you know that 1 represents 1 beat, 2 represents 2 beats, 3 represents 3 beats, 4 represents 4 beats, 5 represents 5 beats, and so on and so forth. right? So that means that as you move from the left to the right, the number of beads is increasing, right? Which means that as you move towards the right on this list, the number that comes first is always smaller than the number that comes next. Meaning that, for example, 1 is less than 2. Then you can say that 2 is less than 3. Then you can say that, for example, 3 is less than, you can say that essentially 3 is less than 4, for example. Then you can say that, for example, 4 is less than 5. Or you can even say that 1 is less than 4, for example. Because 1 is essentially to the left of 4, for example, right? And so on. So this is the way that I have written our numbers over here. What this means is that I've written the numbers in an ascending order. In an ascending order, what that means is that the numbers are ascending, meaning that they are getting larger and larger. And you know that essentially when you ascend, what that actually means in the English language, the word ascend, what that means is that if you have a mountain, something like this, this is the base of the mountain, this is the top of the mountain, and you have essentially, if you move essentially towards the top of the mountain, you're ascending the mountain. If from the top, if you move towards the bottom of towards the base of the mountain, you are descending the mountain, right? So this is ascending, and this is descending. And so then when you're ascending, this essentially you're getting towards larger and larger numbers, meaning that 1 comes over here, 2, 3, 4, 5, 6, 7, and for example 8 comes over here. You are ascending, going towards larger numbers. And when you're descending, you're moving from the larger number towards the smaller number. Meaning from 8 you come to 7, you come to 6, you come to 5, you come to 4, you come to 3, you come to 2, and then you come to 1. So then when you write your numbers in an ascending order, that means that you start from the smallest number, and then you will end up with the largest number over here, right? So, and when you write your numbers in an ascending order, what that means is that as I mentioned before, as you move from the left towards the right, the numbers are getting larger and larger and larger, right? Now you can use this property of this list in order to compare your numbers. Meaning that then if you have your numbers, for example, 8 and 12, you have your numbers 8 and 12. If you were to compare them, you see that 8 is over here, and then you have 10, you have 11, you have 12, and so on and so forth. You see that 8 comes over here, 12 comes over here. So because of the fact that 8 is located on the left hand side of 12, then we can say that essentially 8 is less than 12, right? Although, I mean, none of this is any sort of mathematical proof, but, well, at this stage, it's okay to argue this way. And then basically I'm looking for the greatest number, so I pick the 12, which is the greater number, and I will basically compare it with 6 over here. And you see that basically 6 is right over here, and 12 is right over here, and because 6 is located to the left of 12, then I can say that 6 is less than 12 basically, right? So that means that 12 is the greater number still. So 12 was greater than 8, it's also greater than 6. That means that 12 is the greatest number on this list over here. And so the greatest number over here would be basically 12, right? That's basically how you compare numbers at this stage. Now, there is one thing that I need to talk about right now, and that is the fact that basically, well, of course, you know that basically we are doing these videos for the sake of calculus, right? And well, kind of, I mean, sometimes I actually have to make the assumption that you're either, I mean, that you're at some, well, higher class, for example, at least class 6, 7, 8, and 9, something like that, and you're either getting ready for calculus, or you're, well, or essentially you're at class 10 or so, and now you're, well, I mean, hopefully not, but maybe stuck over there, and now you need, and now you've come to these videos to help you, right? So sometimes I make the assumption that you're essentially in a higher class, and when I do so, I have to bring in a little bit more advanced mathematics. And now, if you were in a higher class, the way that you could essentially compare these numbers is that you could say that you could essentially use the same model that we used before. Meaning that when we wanted to essentially to compare, for example, 8 and 12, we depicted 8 over here. So we said that this is what, for example, this is the number 8, and then 12 would be this number over here. So this is 12, and then we wanted to compare. So then we said that then I said that I have 8 beads over here, so that these are my 8 beads, and then it seems that this number essentially has 4 beads more than this number. So based on the fact that it has 4 beads more than this number, then I can say that 12 is greater than 8. Or I can say that essentially 12 is the same number 8 plus basically 4 more beads, right? So then this I can write it mathematically as well as a general statement. I can say that basically 12, I can call it, for example, A, is greater than some number, for example, 8, I'm going to call it B, if basically if A is equal to basically B plus some number C, which is this 4 over here, where this number over here is some number greater than or equal to 1. It could be a 1 or a 2 or a 3 or a 4 or any number, basically, meaning that this number can be greater than this number by any amount, meaning the difference could be a 1, could be a 2, could be a 3, or any number essentially for that matter. So C is greater than or equal to 1, and then we can also say that essentially C belongs to the set of integers, meaning that it's essentially the set of integers is essentially this set over here Z, which is essentially contains all of these elements 0, 1, 2, 3, all the way up to positive infinity, meaning that you could say 3, 4, 5, and so on and so forth. Or basically negative 1, negative 2, negative 3, and so on and so forth, all the way up to negative infinity, meaning negative 1, negative 2, negative 3. Now, of course, over here we are saying that C is greater than or equal to 1, which means that essentially we are talking essentially about only about this portion over here, meaning that C is not supposed to be a negative number, or it's just essentially not 0. So we are forgetting about this part, and we are saying that C belongs to this set, meaning that, for example, C is not supposed to be, for example, a 1.2 or a 1.253 or essentially some real number like this. That's essentially the reason why I've put this over here, to make this things simpler essentially. So that's basically the whole story. Now this way, now using this argument or this statement, you can essentially compare any two numbers, meaning that you can, for example, again, by two, if I were to essentially compare the same numbers 8 and 12, then I could simply say that I'm comparing the numbers basically 8 and 12. So then I'm going to say that we said that A is greater than B, meaning that 12 is greater than 8. Now instead of if, I could write because, right? Because you would write it as 3 dots over like this. Because essentially 12, A is equal to B plus C, which means that 12 is equal to 8 plus some C, which is in this case is 4, where essentially where this number 4 is greater than or equal to 1, and of course 4 belongs to the set of integers. That means that essentially, of course, because the number 12, in the number 12 there is already an 8 and another additional 4, which means that 12 is greater than 8. That's essentially all that this statement is talking about. Okay. Now, now that we know the theory behind the comparison of comparing numbers, I will do the rest of these in the next video. Thank you.